Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good morning to everyone. So now I will continue on chapter 2 for course Advanced Thermodynamics part 2. Previously in part 1 we have explained and discussed the concept of energy and defined its various forms, and we discussed the nature of internal energy. We also defined the concept of heat and the terminology associated with energy transfer by heat, and we also discussed the three mechanisms of heat transfer, which are conduction, convection, and radiation process. In part 2, we will now define the concept of work, including electrical work and several forms of mechanical work. I will introduce again and explain the first law of thermodynamics, energy balances and mechanisms of energy transfer to or from a system. We will determine that a fluid flowing across a control surface of a control volume carries energy across the control surface in addition to any energy transfer across the control surface that may be in the form of heat and or work. We will define the energy conversion efficiencies and the equations related, and we will discuss the implications of energy conversion on the environment. Okay, let's continue. First, electrical work. I already summarized it here, some important equations for electrical work. Okay, electrical work equation, WE equal to Vn. Electrical power, power denotes with the capital letter W dot E equal to Vi. When potential difference and current change with time, the integration of We, and when potential difference and current remain constant, We equal to Vi delta T. Okay, so current I, potential difference is V. Now let's see the mechanical forms of work. There are two requirements for a work interaction between a system and its surroundings to exist. First, there must be a force acting on the boundary. Second, the boundary must move. Remember, as you can see in this figure, if there is no movement, no work is done. Let's see the equation for work. Work equal to force times distance. When force is not constant, we integrate F ds from 1 to 2 and we will get the work. Remember that the work done is proportional to the force applied and the distance travelled as. Here I already summarized the equations for shaft work. Okay, first equation regarding torque. Okay, a force F acting through a moment arm R generates a torque. Okay, this force acts through a distance S equal to 2 pi Rn, and we just substitute this equation to this equation and we will get the shaft work. Remember, shaft work unit SI is kilojoule. Okay, in order to get the power of this shaft work, we will get this equation W dot shaft equal to 2 pi N dot T, and the unit SI is kilowatt. For spring work, when the length of the spring changes by a differential amount dx under the influence of a force F, the work done is W spring equal to F dx. Okay, dx is the elongation of a spring. Okay. For linear elastic springs, the displacement x is proportional to the force applied, F equal to kx. And substituting, integrating these two equations, we will get W spring equal to 1 over 2k x2 the final displacement and x1 the initial displacement. Unit SI is kilojoule. Okay? Unit SI for work is kilojoule. Now, let's see the equation for work done on elastic solid bars. Okay, I believe most of you already learned about this. Okay, work done on elastic solid bars, W elastic. Okay, integration from point 1 to point 2 F dx. Okay, the elongation. Work associated with the stretching of a liquid film can be calculated using this equation. Now, let's see the work done to raise or to accelerate a body. First, the work transfer needed to raise a body is equal to the change in the potential energy of the body. Second, the work transfer needed to accelerate a body is equal to the change in the kinetic energy of the body. Okay, remember potential energy and kinetic energy. So, we can summarize that non-mechanical forms of work uh, are divided into electrical work, magnetic work, and electrical polarization work. What is electrical work? Electrical work is the generalized force is the voltage, and the generalized displacement is the electrical charge. While for magnetic work, the generalized force is the magnetic field strength, and the generalized displacement is the total magnetic dipole moment. For electrical polarization work, the generalized force is the electric field strength, and the generalized displacement is the polarization of the medium. Now, let's recap on the first law of thermodynamics. We already discussed this law on the first chapter. We already understand that the first law of thermodynamics, the conservation of energy principle, provides a sound basis for studying the relationship among the various forms of energy and energy interaction. The first law states that energy can be neither created nor destroyed during a process, but it can change forms. For all adiabatic processes between two specified states of a closed system, the net work done is the same regardless of the nature of the closed system and the details of the process. You can see two examples here. Now, let's see the energy balance equation for the first law of thermodynamics. The net change, increase or decrease in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during the process. So, total energy entering the system minus total energy leaving the system, we will get change in the total energy of the system. E in minus E out equal to delta E system. Okay, energy change equal to energy at final state minus energy at initial state. Okay, it's simple like this. Okay, delta E system equal to E final minus E initial or E2 minus E1. Actually, this energy change can also be summarized with delta E equal to delta U plus delta KE plus delta PE. What is U? U is internal energy. KE is kinetic energy and PE is potential energy. Okay. It also summarized here. Delta U equal to M U2 minus U1. Delta KE equal to 1 over 2 M V2 squared minus V1 squared. Potential energy mg times with z minus z1. Okay, z is the height. Now, let's see the mechanisms of energy transfer E in and E out. I already summarized it here, some of the equations of the energy transfer. Okay, these equations implies the heat transfer, work transfer, and also mass flow. For a closed mass involves only heat transfer and work. The energy content of a control volume can be changed by mass flow as well as heat and work interaction. Okay, actually we already discussed this in chapter 1. Now, we will continue on the next subtopic that is important in the chapter 2. energy conversion efficiencies. What is the meaning of efficiency? Efficiency is one of the most frequently used terms in thermodynamics, and it indicates how well an energy conversion or transfer process is accomplished. So, how can we calculate the efficiency of a things? First, we want to calculate the performance. Okay, performance equal to desired output over required input. For example, the efficiency of a water heater. The ratio of the energy delivered to the house by hot water to the energy supplied to the water heater. Then we can get the efficiency of each type of water heater. Now, this is the important equation for calculating the efficiency. Okay, heating value of the fuel means the amount of heat released when a unit amount of fuel at room temperature is completely burned and the combustion products are cooled to the room temperature. Lower heating value, LHV, means when the water leaves as vapor. Higher heating value, HHV, means when the water in the combustion gases is completely condensed and thus the heat of vaporization is also recovered. So the efficiency for combustion equal to Q over HV. Q equal to amount of heat released during combustion process. HV is the heating value of the fuel burned. What is the definition of a generator? Generator is a device that converts mechanical energy to electrical energy. So the efficiency of a generator can be evaluated by the ratio of the electrical power output to the mechanical power input. Thermal efficiency of a power plant is the ratio of the net electrical power output to the rate of a fuel energy input. Let's see the equation of overall efficiency of a power plant. Okay, overall equal to combustion, thermal and generator. Okay, denotes with this equation. Using energy efficient appliances, it can conserve energy. It helps the environment by reducing the amount of pollutants emitted to the atmosphere during the combustion of fuel. The combustion of fuel produces carbon dioxide, causes global warming. Nitrogen oxides and hydrocarbons cause smoke. Carbon monoxide toxic. Sulfur dioxide causes acid rain. Now, let's see the efficiencies of mechanical and electrical devices. Okay, the equation for mechanical efficiency can be seen here. The effectiveness of the conversion process between the mechanical work supplied or extracted and the mechanical energy of the fluid is expressed by the pump efficiency and turbine efficiency, which you can see in the equation below. Okay, please also read thermodynamics book regarding this pump and turbine efficiency. Okay, I already summarized it here for the pump efficiency, generator efficiency, pump motor overall efficiency, and turbine generator overall efficiency equation. This kind of equation or this kind of calculation will come out during your first test. Now, the final part of the chapter 2 is the discussion between energy and environment. The conversion of energy from one form to another often affects the environment and the air we breathe in many ways, and thus the study of energy is not complete without considering its impact on the environment. Pollutants emitted during the combustion of fossil fuels are responsible for smoke, acid rain, and global warming. The environmental pollution has reached such high levels that it became a serious threat to vegetation, wildlife, and human health. A little bit discussion on ozone and smoke. Okay, you also can read this in thermodynamics textbook. Okay, I summarize it here. Smoke is made up mostly of ground level ozone, but it also contains numerous other chemicals including carbon monoxide, particulate matter such as soot and dust, volatile organic compounds such as benzene, butane, and other hydrocarbons. While hydrocarbons and nitrogen oxides react in the presence of sunlight on hot, calm days to form ground level ozone. This ozone irritates eyes and damages the air sacs in the lungs, where oxygen and carbon dioxide are exchanged, causing eventual hardening of this soft and spongy tissue. It also causes shortness of breath, wheezing, fatigue, headaches, and nausea, and aggravates respiratory problems such as asthma. The other serious pollutant in smoke is carbon monoxide, which is a colorless, odorless, and poisonous gas. It is mostly emitted by motor vehicles. It deprives the body's organ from getting enough oxygen by binding with the red blood cells that would otherwise carry oxygen. It is fatal at high levels. Suspended particulate matter such as dust and soot are emitted by vehicles and industrial facilities. Such particles irritate the eyes and the lungs. How about acid rain? The sulfur in the fuel reacts with oxygen to form sulfur dioxide, which is an air pollutant. The main source of sulfur dioxide is the electrical power plants that burn high sulfur coal. Motor vehicles also contribute to sulfur dioxide emissions since gasoline and diesel fuel also contain small amount of sulfur. The sulfur oxides and nitric oxides react with water vapor and other chemicals high in atmosphere in the presence of sunlight to form sulfuric and nitric acids. The acids formed usually dissolve in the suspended water droplets in clouds or fog. These acid-laden droplets, which can be as acidic as lemon juice, are washed from the air onto the soil by rain or snow. This is known as acid rain. Lastly, the greenhouse effect, global warming, climate change. Greenhouse effect. Glass allows the solar radiation to enter freely, but blocks the infrared radiation emitted by the interior surfaces. This causes a rise in the interior temperature as a result of the thermal energy buildup in a space. The surface of the Earth, which warms up during the day as a result of the absorption of solar energy, cools down at night by radiating part of its energy into deep space as infrared radiation. Carbon dioxide, water vapor, and trace amounts of some other gases, such as methane, nitrogen oxides, acts like a blanket and keep the earth warm at night by blocking the heat radiated from the earth. The result is global warming. These gases are called greenhouse gases, with carbon monoxide being the primary component. Carbon monoxide is produced by the burning of fossil fuels such as coal, oil, and natural gas. Okay, you can learn and study more about the uh, global warming, okay, the greenhouse effect by your own. Okay, so in part 2, chapter 2, we actually learn the energy transfer, okay, by heat, energy transfer by work, mechanical forms of work. Okay, we recap on the first law of thermodynamics regarding energy balance, energy change of a system, mechanism of energy transfer. Okay, heat, work, and mass flow. We also learn about energy conversion efficiencies and also the relation between energy and environment. Okay, and that's end the chapter 2. I will see you on chapter 3. After you finish chapter 2, I will assign you an assignment. Okay, please remember that you have to submit assignment. Okay, after you watch chapter 2 before the end of 21st November. Okay, because on 22nd November we are going to conduct a class asynchronous still in uh, YouTube video. Okay, But before that, you need to submit the assignment that I will post in Google Classroom. So I will see you on the next YouTube video on chapter 3. Thank you. Assalamualaikum warahmatullahi taala wabarakatuh.